Okay, so hello again. So for this week, we did we watched the video on the nuclear bomb um presentation or video on Canvas. So this is my explanation of the nuclear bomb. So um just to start off, we have atomic bombs. Um So most people think that atomic and nuclear bombs are the same thing. They are not, but both are considered nuclear weapons. For atomic bomb, the main reaction of fission must occur for an explosion. Uranium 235 is needed for a nuclear weapon for an atomic bomb. The content of 235 isotope of uranium should be at least 80%. Plutonium-239 could also work as a fallback, but it is very rare to find, and you can also create it. 4 to 5 critical masses are needed. The main one is implosive. A guided explosion is needed. The outside explodes, which then causes the uranium or plutonium to shrink towards the shockwave, causing the big explosion, as we know as the mushroom clouds and all that stuff. Um, so next, nuclear energy. Nuclear arms are weapons of mass destruction that use nuclear energy to make an explosion. The energy is then contained in an atomic nuclei, which is then released in the nuclear reaction in radioactive decay. The main difference in how they explode, um, hydrogen bomb. And this specific bomb energy is released due to thermonuclear fusion. Uh, Deuterium and tritium contribute toward the explosion. Lithium hydride is the main effective substance, but cannot be set off by itself. So it then uses a detonator, which is the simplest way to explain it on how it is able to get set off and create that big explosion. Also in the video, they were saying there is no limit to the power of a hydrogen bomb, essentially stating that pretty much if someone wanted to, they could pretty much make a bomb that would pretty much kill all life itself on Earth, which we definitely don't want to happen. Um, so for nuclear bombs, usually uranium 235 is used in nuclear weapons. Um, the nuclear bomb is measured in TNT equivalent. Um, a certain amount of TNT is needed to produce the same energy. So the most famous nuclear bombs are obviously the little boy and a fat man. Um, the first one was dropped in Hiroshima, had a capacity of 13 to 18 kilotons of TNT. The second bomb destroyed the city of Nagasaki. 3 days later, this one had a capacity of 21 kilotons of TNT. And the main reason why we kind of measure nuclear bombs in TNT is because it's pretty much the most known, like as far as measurement for explosive. So that's typically why we would use TNT over any other measurement. And then lastly, for radiation. Um, Radiation is one of the factors that is a result of a nuclear bomb. Is There are three types of ionized radiation. They are alpha, beta, and gamma. All three would contaminate the area of where the bomb would happen or yeah, would take place. Alpha would not do much harm. Um, your clothes and such would pretty much protect it unless like your skin is like out and open. It could maybe get affect you that way, but it's not very as strong as the other two. Beta radiation can cause harm. Some of the damages could be radiation burns. and cataracts. This one is a lot more if you're close. I mean, you don't have to be super close, but um, it's not as has as big of a grasp as gamma radiation. But it says you can feel these effects from being a certain amount of meters from away from the explosion. Um, when it comes to gamma radiation, unfortunately, not much can protect you from the radiation itself. Only in the video it says only thick layers of concrete and lead can kind of protect you from the gamma rays. Um, Consequences of being exposed to gamma radiation would be cancer, gene mutation, and radiation sickness. Um, and yeah, these are pretty much the explanation on kind of how a nuclear bomb is formed and the different types as far as the hydrogen bomb, the nuclear bomb, the atomic bomb, and how they kind of correlate to each other. But yeah, there's all weapons of mass destruction, and hopefully none get used anytime soon, nor um on any of us, or we use any, But yeah, that's pretty much it. Thank you for watching, and yeah.